You arrived 2 hours early. You shuffled through a security line, took off your shoes, repacked your bag, found your gate, and boarded a metal tube weighing over 400 tons that flew you through the stratosphere at 900 kilometers an hour. And the entire time, tens of thousands of other people were doing exactly the same thing around you. Nobody crashed into each other. The bags mostly arrived. It felt almost routine. But what you walked through was one of the most complex logistical systems ever built. And almost none of it is visible to the passengers moving through it. The largest airports, Hartsfield-Jackson in Atlanta, Dubai International, Beijing Capital, each process over 100,000 passengers every single day. That is a coordinated flow of human beings, luggage, fuel, aircraft, crew, food, and cargo, all moving simultaneously across a space the size of a small city on a schedule measured in minutes. It starts before the plane lands. Every approaching aircraft enters a managed stream controlled by air traffic controllers working in towers and radar facilities that may be kilometers away. Researcher Mika Ensley, who spent decades studying situational awareness in high-stakes environments, found that air traffic control is one of the highest cognitive load jobs in existence. Controllers hold a three-dimensional mental model of dozens of aircraft simultaneously, each at different speeds and altitudes, and sequence them onto a single runway. The spacing between landing aircraft is not arbitrary. It is calculated around wake turbulence, the invisible rotating columns of air trailing behind large planes that can flip a smaller aircraft following too closely. Controllers sequence heavy jets, medium aircraft, and regional planes in a specific order to manage this and maximize runway throughput. Once the plane lands, the ground choreography begins. Every arriving aircraft goes through a turnaround, the tightly timed process of unloading passengers, offloading baggage, cleaning the cabin, restocking supplies, refueling, loading new cargo, and boarding new passengers, all within a window as short as 25 minutes for a short-haul flight. Every minute an aircraft sits at a gate not flying costs an airline thousands of dollars. The system is engineered around keeping planes in the air. The baggage system is its own infrastructure. When you drop your bag at check-in, it enters a network of conveyor belts, scanners, and sorting machines that can stretch for kilometers beneath the terminal floor. Each bag is tagged with a barcode linked to your flight. Optical scanners read those tags at speed, routing bags automatically to the correct outbound belt. At major hubs, this underground network processes tens of thousands of bags per hour. The failure rate is tracked obsessively. Baggage mishandling costs the industry over $2 billion a year globally. Security is a carefully engineered bottleneck. TSA data shows a standard screening lane processes roughly 150 passengers per hour. Airports calculate lanes needed by modeling peak passenger volumes across every hour of the day. Fast-track lanes for experienced travelers are not just a convenience. They are a deliberate flow management tool that separates high-throughput passengers from lanes requiring more intensive screening, increasing overall capacity without adding physical space. Gate assignment is a scheduling problem of staggering complexity. Airlines use software to assign gates based on aircraft size, turnaround time, connecting flight proximity, and terminal capacity, optimizing hundreds of variables simultaneously. When something breaks, a delayed inbound flight, a mechanical fault, a crew member who timed out on legal flying hours, the ripple effects move through the entire system. A single delayed aircraft can displace gate assignments for a dozen subsequent flights. The Operations Control Center managing this for a major airline runs around the clock with hundreds of staff re-optimizing continuously. What holds it all together is standardization. Every airport operates on shared protocols developed by the International Civil Aviation Organization, the UN body governing global aviation. A pilot landing at an unfamiliar airport in a foreign country reads the same runway markings, interprets the same approach lighting, and communicates with the tower using the same conventions as at home. This invisible layer of global standardization is what allows the system to scale across thousands of airports without collapse. So the next time you arrive 2 hours early and take off your shoes, you're not waiting for bureaucracy. You're stepping into one of the most precisely engineered human systems ever built. And it's moving 100,000 people through it today, just like yesterday, just like tomorrow.